How's it going, everyone? Welcome back to the channel. My name is John and I'll give you regular updates in the world of space. At the moment everyone's watching NASA and the Artemis moon missions, but while all that attention is focused on the US, China is quietly preparing for one of the most dangerous tests in human spaceflight. This test isn't about landing, it's not about space stations, it's about one brutal question. If the rocket starts to fail at the worst moment of launch, can you save the astronauts? Because if this system works, China moves one big step closer to putting humans on the moon before 2030. So China is developing a brand new spacecraft built specifically for the future, not just low Earth orbit, but lunar missions. This vehicle is being developed by the China Aerospace Science and Technology Corporation. It's the main state space contractor. Think of this as China's next generation astronaut taxi, designed to replace their current crew systems. So let's break it down. The spacecraft has two main parts. So you have your crew module, they sit there and they return to Earth in that. Then you have the service module, which powers engines and life support in space. The crew module is partially reusable. It can carry up to 6 astronauts or astronauts plus cargo. And most importantly, it's designed from the start with moon missions in mind. To understand this test, you need to understand max Q. Max Q is the moment during launch when the rocket is under maximum stress. You've got the rocket going very fast, thick atmosphere, huge air pressure, massive vibration. It's almost as if you're driving at extreme speed directly into a storm. This is one of the most dangerous phases of ascent. Now imagine something goes wrong right there at max Q. That's where the launch escape system comes in. A small rocket tower sits on top of the capsule. If there's danger, it fires and literally rips the crew module away from the exploding rocket. So this test is looking to see, can the system react fast enough? Can it survive the extreme forces? And can the astronauts be pulled out safely? This will not be a nice thing that happens to astronauts if they need it. This is a system that actually saves lives. This spacecraft is meant to fly on China's new heavy crew rocket from the Long March program. This isn't their oldest station rocket. This is a system aimed at deep space and lunar missions. So what China is testing here isn't just a capsule, it's part of a whole moon transportation system. Now here's the part that sounds like science fiction. Instead of landing on legs like SpaceX, the rocket would be caught mid-descent by cables and nets. Think aircraft carrier arresting cables, but for a falling rocket stage. So why the ship itself is high tech. To catch a rocket, the ship cannot drift at all, so it uses something called dynamic positioning. Sensors measure wind, waves, movement, a computer constantly calculates drift, thrusters fire automatically to keep the ship locked in position. This platform uses DP2 level systems, meaning backups. If one system fails, another takes over. That level of redundancy is exactly what you want when you're trying to catch a falling rocket. So why this matters for China's moon missions going forward? This abort test is a safety milestone. If it succeeds, China proves astronauts can be saved in worst-case launch scenarios. It moves them closer to crew missions to Tiangong space station and pushes forward human moon landings before 2030. This is the kind of step that happens quietly, but it's essential. While everyone is watching the NASA and Artemis mission unfold, and while headlines focus on big launch dates, lunar landings, and flags on the moon, China is doing something much quieter, just as important. They're steadily checking off the hardest engineering and safety challenges required for human lunar missions. These aren't the kind of milestones that make front page news. You don't get dramatic touchdown footage, you don't get astronauts bouncing across the lunar surface. What you get instead are tests like this one, systems designed for the moments when everything goes wrong. Because getting to space isn't the hardest part, surviving the journey is. A max Q abort test isn't about optimism, it's about realism. And it's about accepting that rockets fail, systems break, and physics don't care about timelines or national pride. And when that happens, the only thing standing between the crew and disaster is the quality of the engineering decisions made years earlier. And that's what makes this test so important. It's not flashy, but it's foundational. If China wants to send astronauts beyond low Earth orbit, if they want to fly people aboard lunar orbit or eventually down to the moon's surface, then systems like this have to work every single time. Every major human space program has learned that safety systems aren't optional, they're the mission. What we're seeing here is China deliberately taking those lessons head on. Not skipping steps, but validating the most stressful, unforgiving phases of flight first, when the margin for error is basically zero. So while attention stays fixed on Artemis timelines and launch windows, China is quietly building confidence in the systems that actually decide whether a crew lives or dies. Sometimes the most important milestones in space exploration aren't landings, they're not even launches. They're the moments when engineers ask, what happens if everything goes wrong, and can we still bring the crew home? Because space exploration isn't just about going far, it's about surviving the journey, and making sure that when humans push further into space, they still have a way back. As always, thanks again for watching, and I'll see you in the next one, guys.